More than 80% of developers use Git and GitHub for version control and CI/CD. That's not just a trend, that's the backbone of modern software development. According to the 2020 Stack Overflow Developer Survey, Git and GitHub have become the go to tools for developers worldwide. This incredible adoption rate highlights the importance of version control and collaboration in modern software development. Git and GitHub are essential for managing code, tracking changes, and working seamlessly with teams. It's no wonder they're so popular. In this video, I'll be showing you how to master the DevOps CI/CD pipeline. From version control with Git to seamless integration and deployment with GitHub, I'll be breaking it all down step by step. And we are starting off with Git. At its core, Git helps you track and manage changes to your code base. It gives you a detailed and accessible history of every single change that you've made to your project, whether that's adding a new feature, fixing a bug, or even refactoring code. This is exactly what Git provides, a comprehensive record that not only enhances your ability to manage your code, but it also fosters collaboration with your teammates. A version control system like Git is indispensable for managing software updates over time. It allows multiple developers to work on the same project simultaneously without the risk of overriding each other's work. This capability is vital in collaborative environments where team members may be spread across different locations or even time zones. With Git, everyone can work on their respective parts of the project and merge their contributions seamlessly. When working in larger teams or even solo on larger projects, version control is a necessity. It helps you avoid overriding changes, experiment freely, and it makes collaboration much easier. These tools are crucial for maintaining the integrity and efficiency of software development projects, particularly those involving large teams or complex code bases. First, let's install Git. You can download and install Git manually or use winget, the Windows Package Manager command line utility. You should watch this video. Every Windows user must know these 10 winget commands, where I'll walk you through getting started on using winget to manage applications on your Windows computer. You can easily install Git by opening a command prompt to quickly install it with a single winget command. Winget will proceed installing the application. You can see the progress in the dialog box that pops up as the installation proceeds. When it completes, the dialog box will automatically close and winget will finish the installation. Alternatively, head over to the Git website and grab the latest version for your operating system. Follow the easy installation steps to manually install it yourself. Pause the video and install Git. When that is complete, you will be configuring it to create a more personalized, efficient, and reliable version control environment that caters to your specific needs and workflows. This not only enhances your productivity, but also ensures smoother collaboration with your team. You will start by adding your name and email address to the global configuration. This will allow Git to easily identify who has made each change in a codebase. When setting your Git configuration, keep in mind that GitHub will require that you use an email address that matches one that has been added to your GitHub email settings. This is my email settings page on my account. I have one email that's available if I try to set up a Git configuration with a different email. When we try to connect GitHub to Git, it will not work. So the emails must match. If you want to use an alternate email address, add it to your list of emails on GitHub. We will be covering this later in this video when we create an account for GitHub. Open a terminal or command prompt and enter this command, changing the username to your own. When you have entered the command, execute it to create your username in the Git configuration. When that is complete, alter the command to change it from username to user email, and then provide the user email that you are going to be using in Git and GitHub. When you are finished, execute it. You have now set your Git username and email in the Git configuration file. You should set a default text editor for Git. Setting the default editor for Git is essential for several reasons. It allows you to input commit messages. It allows you to edit the list of commits during a rebase, assist conflict resolution when resolving merge conflicts, creating tags and notes, and editing your Git config files like Git config or Git attributes. By setting your default editor in Git, you ensure that all text editing tasks are handled in an environment where you are the most comfortable. These tools offer features like syntax highlighting, auto completion, and integration with version control systems. From the versatile Visual Studio Code to the lightweight Sublime text, each editor brings unique strengths to the table. And you should try them all out and choose the one that suits you. I picked some of the most popular editors along with their aliases to get you started. Choose one of the editors from this list. You need to use the alias when you are setting your default text editor in the Git configuration. So if you want to use Visual Studio Code, you would use code as the alias to set the editor. You can choose your preferred editor by replacing the alias in the command to configure the editor. For example, to set Visual Studio Code as the editor, you can use this command. If you chose another alias to use, replace code in this command with that alias. When you are finished, execute it. Adding the wait flag is used to ensure that Git pauses and waits for you to finish editing commit messages or files before continuing. If you don't add this flag, Git might not capture all of your changes if the editor does not wait for you to finish editing. You are collaborating on a project with a team of developers using different operating systems: Windows, Mac OS, and Linux. Each of these systems handles line endings differently. By configuring your line endings correctly in Git, you ensure a unified code base, making it easier to manage and maintain. This setting in Git is your best friend here. When you set to true on Windows, Git automatically converts LF to CRLF on checkout and back to LF on commit. On Unix-based systems, setting it to input will convert the CRLF to LF on commit, but leave LF unchanged on checkout. To configure Git to handle line endings automatically, use this syntax for your Windows machine. When you finish typing the command, execute it. If you were running a computer on Linux or Mac OS, then you will have to use a different configuration to configure the line endings. It is the same up until the point you would change it from true to input. Changing the default branch name from master to main in Git has become a widely adopted practice for several reasons. The move towards using main reflects a conscious effort to use language that is inclusive and free of any historical connotations. It's a small but significant step towards making the tech industry more welcoming for everyone. Main is also straightforward and descriptive, clearly indicating its role as the primary branch where the latest production ready code will live. This reduces confusion for new developers and aligns with a modern naming convention across various tools and platforms. Creates consistency across projects, making it easier for developers to switch between repositories without needing to remember different default branch names. This approach enhances collaboration and is also very efficient. By updating your default branch to main, you're contributing to a more inclusive, clear, and standardized coding environment. It's a best practice that reflects the evolving values and professionalism of the developer community. To set the default branch name to something other than master, you use this command. When you have entered the command, execute it. Viewing your Git config file lets you see how your Git environment is configured. This is especially useful if you're working on multiple projects with different configurations. It also empowers you to customize your workflows. Do you want to set global user information or tweak your editor settings? Viewing your current settings helps you identify areas for fine tuning, ensuring that Git works exactly the way that you need it to. In this video, we've been setting global configuration settings that will affect every project created on your machine. However, you can create project-based configurations. Setting your path to your project folder and omitting the global option will allow you to define and review configurations for each project. This command opens the global Git config file, and you can easily review all of the settings Git is currently using. Your file should contain these same settings. We have been defining these settings throughout this video. Take a moment to review the settings. When you are finished, close the file and exit your editor. The Git command line interface brings the full capabilities of Git directly to your command line. It's your command center for version control, allowing you to efficiently manage your code with precision and control. With the Git CLI, you can instantly execute Git commands to track changes, commit updates, and manage branches. You can easily manage tasks from staging and committing to merging and branching, all from your terminal. And you get instant feedback on your actions, helping you stay in control of your project's history and structure. The Git help command provides instant access to detailed explanations of Git commands, saving you from endless searches. From basic operations like cloning a repository to more advanced strategies such as rebasing or merging, Git help covers it all. It's your guide to understanding every command inside and out. Just type Git help followed by the name of the command, and you get a guide on how to use that specific command, complete with examples and options. For instance, if you append the commit command and execute, it will open up a browser window, providing you with all of the documentation about that particular command. Unlike a static manual, Git Help will give you interactive, detailed information at your fingertips. It's organized, easy to navigate, and incredibly user friendly. But let's start at the beginning. Open up your terminal and type this command. This will give you a list of the main commands that are used, and it's grouped by when and how to use them. It gives you the particular use case as the grouping. As you learn more about Git, you'll understand how these groups are formed. Need more? You can get a list of all available commands by adding the All option. This will give you a list of all commands. And if you want to dig even deeper, you will be able to get a list of all of Git's common guides and helpful documentation using the guide command. When you type this command, execute it. This command categorizes and presents the guides in a logical order, making it easier to find exactly what you need. You can find the contents of each guide by typing Git Help and then adding the name of the guide that you want to view. And just like we saw before when we were looking at the commit command, it will open a browser window with that documentation. So getting comprehensive help is very easy with Git. Now that Git is set up, let's start a project. Open a command prompt and navigate to the directory to where you want to create the project. You can create a new directory, switch to it, and initialize it as a Git repository. First, let's create the directory. Open your terminal and type this command and execute it. Now let's step into that new folder using the change directory command. To start tracking your project with Git, you will initialize a new Git repository. Simply type the git init command creates an empty Git repository or reinitializes an existing one. A Git repository is a folder on your computer where your project files and revision history are stored. It creates a hidden subdirectory named Git in the project directory that contains all the necessary metadata for a repository, such as configuration files, the repository's history, and information about branches. Next, you will add files and commit changes to your new repository. The Git status command provides a complete overview of your working directory and staging area. It helps you keep track of the state of your project, showing you which changes have been staged, which haven't, and which files aren't being tracked by Git. It outputs a summary including the current branch and its status related to the upstream branch, changes to be committed, changes not staged for commit, and new untracked files. Since this is a new project, you have no changes. There have been no commits. We need to add some files to our project to constitute a change that we can stage. Use the echo command to create 2 new files in your project. If you run the status command again, you will now see that you have files that need to be staged. The git add command stages changes for the next commit. It lets Git know what file should be included in your next commit to save in your repository's history. It moves existing changes to the staging area prior to being committed. You can review those changes you want to include in your commit. Always use it before committing to save your changes to a repository. You have multiple options in how you want to add your files. You can add a single file, multiple file, all changes in the current directory and subdirectories, or a specific directory. You can add a single file by adding the file name at the end of the add command. You can add 2 files by adding the second file. You can add all files that are currently in your directory that need to be staged by using the dot parameter. This will include all of the files that need to be staged within your current project. That is what we're going to use here. Type this command and execute it. If you run git status again, you will now see that the files you added have been staged and are ready to be committed. Let's do that. Git commit is a command used in Git to save your changes to the local repository. It takes the changes that you staged using git add and records them in the repository's history. This creates a snapshot of your project at that point in time. A local repository is your project folder on your computer. Git saves stage files as a new commit. Git creates each commit with a unique identifier called a hash and includes the commit message describing that change. The commit is added to the detailed record of the changes to your project, and that facilitates better collaboration with your team members and allows you to revert to a prior commit if needed. Enter this command in your command prompt. Your commit message should be descriptive of the change. A good best practice employed by most developers is to indicate if it's an initial commit when you start a project. Enter this command and execute it. You've now created your first commit message. The commit message should be descriptive about what changes were made. It ensures that the code base is well documented. Now that you know the basics of Git, let's talk about GitHub. GitHub is an online platform that stores Git repositories, making it easy to share your code, collaborate with others, and even showcase your projects. It's like a social network for code, where developers can follow each other, collaborate, and contribute to open source or internal projects. If you don't already have a GitHub account, you will have to create one to connect with developers, to share your projects, and contribute to open source initiatives when you're ready. You'll be prompted to enter your email address, create a username, and set a secure password. Your username will be your identity on GitHub. You'll be guided through a few more steps. You might be asked to verify your email address, choose some preferences, and select topics that may interest you. Once you've filled in the details, click the Create Account button. The GitHub command line interface is the tool that brings GitHub right to your terminal. It allows you to manage your repositories, pull requests, and more. You can do it all, and you don't even have to leave your command line. Command. Installing it is just a matter of running a single winget command. Enter this command and execute it to install the GitHub CLI. Winget downloads the installer and installs the package for you. You should now have the GitHub CLI successfully installed. Now, sure, you could download the GitHub CLI from GitHub and install it manually, but why go through all those extra steps? Save your time and effort and use Winget. After you've installed the GitHub CLI, you have to authenticate your account to start using it. The GitHub Auth Login account will securely connect your GitHub account with the CLI, giving you access to GitHub from your command line. Log into your account by executing this command. You will be guided through the authentication process step by step. Choose between the different options by making these selections. Select github.com for where do you use GitHub. Select HTTPS for your preferred protocol. And you will authenticate using your GitHub credentials, so select yes. How would you like to authenticate? You're going to do it through your web browser. GitHub will give you a one-time code to log in via the browser. Copy it now so that you can use it when GitHub asks for it. Press Enter to open the browser to log into your account. Use the username and password that you created. Now enter the one-time code that GitHub provided when you authenticated in the CLI. Hit Continue. It will ask you to authorize GitHub. Click the button. Now your computer is connected to GitHub. You can now connect Git and GitHub. You have authenticated yourself, and you can connect your project to GitHub, making it easy to sync changes. Using the GitHub CLI, create the remote repository. By entering this command, you are creating a repo on your GitHub account, setting it to public, and setting the source to the project folder in your local repository. When you've entered the command, execute it. It created the repository on GitHub. It was unable to add the remote origin. Origin is the default name given to the remote repository from which you are going to clone your local repository. It's essentially the URL or path pointing to the original source of your code. The Git CLI will allow us to set the remote to origin. That's our next step. This command will set the remote URL pointing to your project on your GitHub account. When you've entered the command, execute it, changing the username on GitHub to your username. Once you have set the remote, you can verify it with Git using the remote verify command. This will tell you where you're going to push your changes and where you will fetch. You'll get everything that exists on your remote repository and pull it into your local repository. This is really useful in team situations where you have multiple developers working on the same project where you need to keep your code changes in sync. You have authenticated with GitHub, created a remote repository, and set the origin. Now you're ready to push the commit that you created before we started working with the GitHub CLI. This command will push your local changes, your local commit, to the main branch on your remote repositories set to origin. When you've entered this command, execute it. Go back to your GitHub account and click on your project. The files you created are now in your repo. Your branch is set to main. The two files are included and they're named using the commit message. You have now successfully created a local repo, a remote repo, and push changes. And this is the key to continuous integration. Pushing changes to GitHub is the key of continuous integration because it automates and streamlines the entire development process. It fosters collaboration with your team members, enhances code quality, and ensures early bug detection. This enables continuous delivery of updates and features. By integrating these practices, teams can achieve a more agile, responsive, and high quality development process. And this is a great practice because it's part of DevOps. Branching is one of the amazing features of Git and GitHub. It enables developers to create separate lines of development within a repository. You do your work on new features, experiment, or fix bugs completely isolated from the main branch. There's no interruptions to the main branch. Once everything's polished and ready, you can merge those changes into the main codebase. This process ensures that the primary version of your project stays rock solid and stable while encouraging productivity. Git's distributed nature is another game changer. Every developer has a complete copy of the project on their local machine. This supercharges performance because it allows for offline work and adds a layer of redundancy. It's a built-in safety net that guards your code and your projects. Code. Creating a new branch is straightforward. Let's say you want to create a new feature. Always make sure that you start from your main branch. You can do that using the checkout command. You add the branch name that you want to check out. And that way you ensure that you start from that branch when you're creating a new feature branch. We only have one branch, so we were already on main, but this is to demonstrate that you've already switched to that branch. You can create and switch to your new branch, bringing along all the code from your main branch. This new branch gives you the freedom to make changes, experiment, and refine any of your features. And you're not touching the main code base. You can create a new branch, again, using the checkout command. You add the branch option to define what your branch name should be. Enter this command and execute it. You have now created a new branch that contains all of the code from main that you can do whatever you want with. That's the beauty of branching. With Git Push, you can push your local branch to the remote repository and set it to track the upstream branch all at once. The upstream branch is your remote repository's branch that your local branch keeps an eye on. This is known as a tracking branch, and it allows your local branch to pull updates from the upstream branch. It keeps your local work synced with the latest changes in the remote repository. Enter this command and execute it to add this new branch to your remote repository. As Git tells us, this new branch has been set up to track the same branch on the remote repository, which is set as origin. We've successfully pushed the feature branch to the remote repository on GitHub. Now every future change will sync between your local machine and the remote branch. Everything got a whole lot smoother. And if you want to verify the remote branch that your local branch is tracking, you can use the git branch command, and it returns a list of branches, their upstream branches, and the latest commits to those upstream branches. We have our main branch, and we also have our new feature branch. This is a great overview because it lets you know exactly where you are with all of your code commits. Now, here's a quick tip. It is a best practice to keep your feature branch up to date with the main branch of a project. That is why you always verify that you are starting with your main branch when you're creating a feature branch. The git fetch command pulls all the latest updates, letting you preview changes before you decide to integrate them into your work. This is a critical feature when you're working on teams because you can update your local repository, adding your teammates' work with your own. This command downloads the latest commits, branches, and tags from the remote repository into your local repository. It doesn't merge them automatically because it gives you a chance to review what was updated. This avoids conflicts by allowing you to prepare for the changes in advance. It's a way to manage and integrate updates smoothly. The git fetch command will fetch all branches and updates from your default remote, which is usually origin, which we know we've set that to. So execute this command, and this will fetch any updates. Now, there aren't any updates because this is a brand new project and we've been working solo. But when you're working with teams, it would give you the latest changes. Do you want to fetch from a specific branch? No problem. Git fetch can handle that. You tell it that you want to fetch from the repository. Our repository is my first project. And you want to fetch the branch, my first feature. Enter this command and execute it. And Git has fetched your feature branch. After fetching, you can expect the changes showing you the latest commits on the remote main branch. Do that using the log command. This shows you your commit, the date and the time, and who made it. And it includes the commit message. Now that we have a new branch, we're ready to make some changes so that we can create a commit and demonstrate how to merge branches. We'll add a new file, again using the echo command. Enter this command to add a new file, which will track a change in the repository. We added the file, and now we can see by running git status that we have untracked files that need to be added and staged so that we can create a commit. Using the add command, we will once again add our files. This time we will specify a particular file just to demonstrate its usage. The file is now staged and ready for a commit. Using the commit command, setting the message, we've now created a new commit for our local repository. After setting the upstream branch earlier, all we have to do is enter the git push command, and this will push that commit to our remote repository. It created a new commit with a new hash, and this is a new change that's in the history of our project. A pull request invites your team members to review your code. A code review guarantees that changes are reviewed, discussed, and, if necessary, refined and revised, leading to a more stable code base. With pull requests, the merging process is also very smooth and controlled because you see a clear history of what changes were made, who made comments and approvals, and this makes the whole process transparent and a lot more manageable. Creating a pull request is simple. Using the GitHub CLI in the pull request create command, we are going to push our feature to the main branch with a great description, letting our teammates know what happened. When you enter this command, execute it. The GitHub CLI also allows you to review the pull request from the command line. Use the pull request list command to list all open pull requests, giving you a clear overview of everything right in your terminal. Using this command, it lists out the ID, the title, the branch that's originating from, and when it was created. You can also see the details about a specific pull request by using the pull request number. Instead of using list, or use view and then the ID of the pull request. Using this, I now see that there's a new feature that I want to merge one commit into the main branch that's originating from my feature branch 7 minutes ago. This is the description added when creating the pull request. You can also click the link and view it in your GitHub project. You can always view pull requests in GitHub. Go to your project in GitHub and click the pull request tab. This lists the pull request that was just created. Team members will use the pull request to do the code review. The pull request contains the details of the pull request, who's required to do a code review, who is assigned to do the code review, and any comments they may have about the pull requests. You can also merge the pull requests. Merging will incorporate the changes from the pull request into the main code base. But we're going to do that using the GitHub CLI. After code review is complete and there are no required changes, then the pull request is ready to be merged. Merge the pull request into the main branch using the pull request merge command. You can do that by setting the number for the pull request to be merged. In this case, we only have one, and so we use the ID of the pull request. Enter this command and execute it. We are going to select the first option to create a merge commit. Select yes and submit because we don't want to edit the commit message or the subject. This command merges the pull request into the main branch. You can add options like squash or rebase to customize the merge, but that's for another video. In this case, GitHub has merged the pull request into the main branch, adding the file that we created. It also deleted the local feature branch and switched the local repository to the main branch. Delivering code changes to GitHub is at the heart of implementing CI/CD in DevOps. By adding your code to GitHub, you lay the foundation for a streamlined, automated, and efficient deployment process. It's not just about storing code, it's about transforming how you build, test, and deliver software. The goal of a DevOps pipeline is to streamline the software delivery process, allowing for faster and more reliable releases. Git and GitHub are more than just version control. They play an integral role in the DevOps process. DevOps is about integrating development and operations, and Git helps manage code changes, while GitHub enables collaboration and automated testing. Git and GitHub allow developers to manage and track every change, making it easy to integrate with continuous integration and deployment tools. Continuous integration is a software development practice where code is integrated into a shared repository often, ideally multiple times per day. Each integration is verified by automated build and tests, which help detect errors quickly and improve the quality of the software. GitHub Actions is a continuous integration and continuous delivery platform that allows you to automate your build, test, and deployment pipeline. You can create workflows that build and test every pull request to your repository or deploy merged pull requests to production. GitHub Actions is incredibly flexible and it can connect with other DevOps tools for deployment. Some of the benefits of continuous integration with GitHub Actions are automated tests catch bugs early in the development process. Frequent integration leads to better code quality and more reliable software. It eliminates manual tasks, and that frees up developers to focus on writing code. GitHub Actions can scale with your project, handling multiple jobs and parallel workflows. Continuous integration ensures that every code change is automatically built, tested, and validated. This means that by the time your code reaches the continuous deployment stage, it's already been through rigorous quality checks. Continuous deployment leverages this by deploying only the most stable and reliable code to production, reducing the risk of errors and downtime. This ensures that the software is always in a deployable state and can be released to users more frequently and reliably. You set up continuous deployment by defining a workflow using YAML files and securely store your server credentials. Then monitor the pipeline to ensure it's running smoothly and update the workflow as requirements evolve. The benefits of continuous deployment are that it automates the deployment process, allowing for faster, more reliable releases. It eliminates manual steps, reducing the risk of human error and freeing up developers to focus on code quality. And it provides immediate feedback on code changes, allowing developers to address issues promptly. Embracing the partnership between continuous integration and continuous deployment transforms your development process, making it more efficient, reliable, and responsive to change. Together, they pave the way for a seamless, high quality software delivery pipeline that keeps your users happy and your team productive. You have just taken a massive leap in mastering DevOps. You've now seen the incredible benefits of using Git and GitHub for your DevOps pipelines. Continuous integration and deployment practices reduce errors, speed up releases, and make your projects responsive to change. Modern tech teams need modern tools. If you're excited to learn more about DevOps, I've got tons of tips, tricks, and tutorials coming your way. Do you have any questions or need further help? Drop a comment below and let's get the conversation started. Thanks for watching and taking one more step in transforming your curiosity into expertise.